All right, hey everybody. As was just said, I'm not Lincoln. I'm stepping in for my coworker who had some travel issues. So let's see. We'll just jump right into talking about the role of open source and open hardware in ORAN and 5G. So I come from the University of New Hampshire Interoperability Lab. That is Lincoln, not me. But so what we are at the IOL is a neutral test facility and a strategic resource for companies around the world. We've been doing testing and software development for the last 40 years, providing testing for different great technologies throughout the eras. Right now, we've got around 265 active test plans, and we're constantly making more test plans, myself and Lincoln included. Primarily for me. Oh, sorry. For me, my name is Carter Snay, and I work in storage and blockchain right now. So I'm wearing a different hat, so bear with me, please. But happy to support the group in this area. So as it says, we're connected to the University of New Hampshire, but ourselves, we are a independent test lab, kind of a branch off of it, where we do our own development and our own work there and contribute to the university. So how does this connect to ORAN and why am I here? So we are a ORAN Experience Center. We're a OTIC, and the IOL has a state-of-the-art test facility which we use for PlugFest and big group test events. As right now, we do have a fall PlugFest going on for ORAN that's going to be going up until the next month. Yeah, so we've been focusing on doing end-to-end testing, doing the whole stack, and having multiple different open source projects going on all at once. It's been coordinated a lot by Lincoln going on for the last few months. The IOL is also building a reference testbed for open source and ORAN solutions, and the project is aiming to have publishing Ansible playbooks so that people can get their own solutions and their own testbeds set up pretty off the shelf and easily, rather than having to develop their own things. And as with testing goes, the more standardization, the less variables to introduce unknown issues, and it kind of just makes everything more streamlined. So here to really talk about the power of open source and open hardware. Of course, this is OCP, so that makes sense. So what is the role of open hardware in this space? It was just talked about a little bit before with Evenstar too. But with openness, we'll benefit from having a strong community and strong code base to build off of. So that way, things not being completely proprietary, you can jump from start from here rather than down here and having to build everything yourselves. There is a lot of support in the community for that as well. So this allows for more research opportunities and ties with academia as well, so that it can drive more innovation. So there's lots of questions to be answered, of course, and finding things like how to improve energy usage, maybe even how AI can help manage these networks. And I have to mention AI because it's at every place. So that is something that by adding the openness to this, more people can get involved and lower the barrier of entry and drive innovation forward. So when researchers get involved, they don't look for proprietary things at first. They go to the open source communities. That way they won't have to build the whole RAN themselves. Let's see. So this, in general, will lead to more communication throughout the whole community. Like I said before, it'll make the starting points easier, and it'll just build a better open source ORAN and 5G ecosystem that creates more opportunities for innovation. So here's a spectrum. We're not at just opaque solutions anymore. We're about in the middle with some open APIs and implementations going on right now. And there's still some fragmentation here in terms of testing and certification. So there's still work to do there. And most notably, for implementations of products, there's no ORU here. So that's kind of what is being worked on now as part of the Evenstar and what I'm going to also be talking about in a moment. There's still testing to be defined there as well. So the problem is there's not a way for someone to build a complete end-to-end solution at this point, and that is what this proposal that I'll just talk about soon is going to bridge that gap. So going forward from Project Evenstar is the Project Morningstar proposal. And this is the sub-project or the continuation of the OCP Evenstar project, which aims to focus on the development of the ORU, that third piece that's missing to complete the open source end-to-end adoption whole model and ORAN network. This aims to focus on development of RU in collaboration with the Evenstar project, like I just said. The idea here is that it'll be open source first. That way there'll be enough documentation for people to build it through the use for usable with multiple implementations without having to be rebuilt from scratch. It'll also develop an API for specification for the ORUs, and it'll also have a well-documented SBOM. And it'll be standards-based, it'll work with Yang modules and following the zero trust architecture from ORAN. So here are some of the deliverables of this project. The first one is to complete the design of the ORU from Evenstar and start making prototypes so they can actually start being tested. We'll also then jump to making a second design based on feedback of the Evenstar participants. So we'll have 2 designs here from this project. The second deliverable here is the radio abstraction interface, so the hardware abstraction layer for this specific project. This is how the open operating system will be able to talk to the modular hardware. And of course, trying to make sure that there's a common API so it's not too cumbersome to develop. The third thing here too is the actual open source operating system for the radios. So this is the project that's going to be going on in the Morningstar to actually have easily extensible and weight interface into the open source, or not the open hardware. Now I'll pass it off to you for a moment, if that mic's working.
Sure, Ahsan.
Yeah.
Yeah, thank you,
Yeah, no problem.
Carter. So first of all, thank you for coming and covering for Lincoln. Apparently he got into some challenges and traffic issues in coming to the airport, and he was not able to make it. So I'm Ahsan Aziz, I'm from Xrcomm, and actually we're a startup that's formed out of the Evenstar team from Meta. And we have looked at this problem of creating a modular radio, like during our times at Meta when we were solving this problem for operators. So some of the challenges, of course, we faced or we uncovered is that there are more than 100 allocated bands, globally, and each band actually requires a specific radio hardware design. And some could be high power, low power, different bands, combination of bands, and so on and so forth. And the challenge with the radio is that you can't reuse that hardware as opposed to the DU hardware or the CU. You can't reuse that hardware for different bands. So it's band specific, it's use case specific. So bringing modularity into this whole thing is very, very critical to really reduce the cost and enable like faster turnaround of developing multiple bands. And so this was actually the foundational careabouts, where Evenstar Radio was designed. And at that time we were working with operators, doing this work. And then when Evenstar ended, this design was actually contributed to OCP. And the first round or the first proposal that we have is actually to really bring back the Evenstar design and enable it and provide it to operators and provide it to different entities who are really interested, even in the private network space, to explore and give us feedback. And while going into this, we will start working on this second design. But here is sort of what is available. Like, as you can see in this diagram, like it's a full modular radio with the mechanical PA, the digital board, the power supply, all of these units designed, and it was actually going through all RF testing. And so this is a fully, complete, I should say, radio design with the software pieces still need to be developed around it. Okay, and so that the first round, the first proposal, what we call is the design one of the ORU hardware, was to really bring back this design back and enable it with the software so people can start really using this. And the second phase of it is actually to come up with a new design, which we are calling the Morningstar ORU design, and that would evolve that the event star design. And there's more than one reasons to do this, and one is the support for ORAN alliances. So when we were actually looking at working with ORAN Working Group 7, one of the challenge we saw was that there was not an open hardware available. So all the hardwares that were offered in the Working Group 7 were closed or not even offered. And it was pretty much like very difficult to make any progress in that space. So having an open white box solution over there would significantly enable both the research in the industry space and the academia, and really for ORAN to prove out some of those interface and just going, is 7.2b the best option? Is 7.2c the best option? What are the power, the different sleep modes? How do you activate them? How do you use AI/ML to kind of enable all of that? And really squeeze out the performance from the hardware. So that actually requires a real hardware to be present, and Working Group 7 didn't have that, or doesn't have that. And so that would be one of the contribution where we think that having an open hardware like this will really enable Working Group 7 to make significant progress. And then also, if you look at the ORAN like the radio vendors, we're thinking that this actually gives them an opportunity to evolve and create new designs pretty quickly. Like, because you have, someone can come back with a tri-band radio or a dual band radio, or different frequency bands of interest, different bandwidth of interest, number of channels, and so on and so forth. So this has to be a flexible platform that kind of enables all of that. Then on top of it, there is the other parts, which is actually the signal processing needed, which is, if you look at it in terms of performance improvement, there's the DPD, CFR, PIM cancellation, all the realistic stuff that is really needed for a commercial radio. So need a platform to evolve, to develop, and to quickly spin new variants. So one of the challenges we saw during the early developments of Evenstar was coming up with multiple SKUs very quickly, because the non-ORAN vendors, typically they have a portfolio of product to offer. Whereas like in the ORAN cases, when you're coming up with one radio, if you don't have a modular design spinning a new version is a huge amount of effort. And so that is one of the things we wanted to break that barrier. And so the objective of the design too is to really enable that, where we started the work in Evenstar, but we want to extend it and really get it to the people who actually have different requirements. I'm going to hand it off to you.
Sure, yeah. So this is from the proposal, just showing kind of what we were just talking about there. On the bottom, there's the hardware, and then through the radio abstraction interface and the open source operating system, you're going to have the ability to build kind of whatever needs are required of the different types of networks and different telco companies and everything like that. So I don't know, just creating a open and modular platform, so you don't have to have these really rigid and unmodular hardware implementations. Yeah. And so here's the proposed timeline. So at this point, right now, we're really in the customer and commercial requirements, figuring out what's going on there. But from what I can see, it looks like 2027 is going to be quite an exciting year for this project. And then next steps, so continuing the development of the user requirements from the Evenstar project, and then starting to actually develop the specification for the radio interface based on those requirements. Complete the Evenstar design 1 to start actual prototyping and testing, and then the creation of the ORU open source OS, which will be compliant with ORAN specifications and the RAI specification. So that's it for me. Thank you, guys.
Thank you very much, guys. So, any questions?
Hi, just a quick question. If you can explain how this work is funded and organized. Is it a cohort of companies working with UNH IOL, or are you open for more collaborators? If you can just clarify that.
Well, at this point, of course, we talked a little bit, it's not, it's more of like all the internal researches we have done is self-funded, right? And I think like anything beyond to really take it to the next level of a commercial grade solution, that's where we have applied for funding for that, and we're actually very much open to collaboration. And I think it's like we all have expertise in different areas. Like you've seen, like you know, the University of New Hampshire, they have a lot of expertise in terms of conformance, compliance, certification, all of those parts. We have expertise in RF design and signal processing. So I think, you know, between the two of us, we have, you know, significant amount of experience to kind of pull this off as a commercial radio, but we do need additional partners.
Thank you. We have time for maybe one more question.
So could you talk a little bit more about the rationale for the OS and why you're not leveraging an open source project from Linux, you know, for example, the Zephyr project or something like it?
Actually, you know, I will take it and you can please add on, right? So basically, we are leveraging the Linux Foundation project, like the OpenM plane. And so that is exactly what we're going to be doing. And actually, that's an effort, I guess. Lincoln was here. He would be able to answer a lot more about that because he's the person sort of taking care of that piece of it. But the goal is obviously to use the OpenM plane from an M plane perspective. And from, go ahead.
You said OS on there as opposed to the M-plane server, so I was just trying to understand what you meant.
Yeah. I think, like, go ahead.
I mean, it could have been a complete misspoke. If you want me to pass questions along to Lincoln too, I most definitely can.
Yeah.
Sounds like a good takeaway. Okay, folks, so thank you very much. It was a great presentation.
Thank you.